Okay. Hello, everybody, and welcome to the last of our fall term, I guess, informational sessions about graduate studies in computational and data science. I am Mariana Carrasco Teja. I'm an associate director and assistant research scientist for the Michigan Institute for Computational Discovery and Engineering, or we usually say MICDE. And just a couple of items. Please keep your microphone muted and your video off during the presentation. If you have questions, you can type them in the chat or type, I have a question, but we'll have time for them at the end of the presentations as well. And then there are closed captions available, so you can click the live transcript icon to view subtitles or a full transcript of what's being said. And you will also be able to ask a question with video or audio at the end of this presentation for everybody, or we will do breakout sessions at the end. And over there, you can also either type your questions or ask each program director your questions. So I'm going to start just first by a few poll questions, just to know who are you and who's attending this info session. So the first poll is just, we would like to know what programs are you most interested in learning about today? Either the PhD, the certificates, either of the certificates. And I'll give it a few seconds for that. Okay. And then our next question is just what degree are you pursuing? Is it a master's degree or a PhD? So your current home, what we call your home department or your home program. Okay, and then lastly, we want to know what is, which is the school or college your graduate work most closely aligned? Okay, so this gives us a good idea. Okay, thank you very much for answering these questions. So I'll get started with the presentation. So just give me 1 second. And today we will cover basic information about graduate studies in computational and data science at the University of Michigan. These are overviewed by either the Michigan Institute for Computational Discovery and Engineering, MICDE, or the Michigan Institute for Data Science, or MIDAS. Today, we will actually cover 3 certificates, one in Computational Discovery and Engineering, and one in Computational Neuroscience, and one in Data Science. And we will go over the joint program, the joint PhD program in Scientific Computing. The first 3 you see listed here are managed by MICDE, and the data science one is managed by MIDAS. And today's presenters, so you can see me, Mariana, and then Krishna Garikipati is the director of the certificate in Computational Discovery and Engineering, and he will present that. Professor Victoria Booth will present about the graduate certificate in Computational Neuroscience. Professor Powell will present the PhD in Scientific Computing. He's the director of the program. And Professor Ivodinov will present the data science certificate. We also have Trish Fountain, that's the education program manager from MIDAS. And if you enroll in that program, you will, she can answer or drive you through the process of enrolling and so forth. And then we have Kristen Thornton, who is the graduate coordinator for the certificate programs, and she's the one that can answer all the tricky questions about courses and enrollment and RACAM requirements. So I'm just gonna go ahead and just give you a brief introduction of what the MICDE is. And the institute was created in 2013. It's an initiative of the University of Michigan, the College of Engineering, the College of Literature, Science, and the Arts, and of Advanced Research Computing. And the mission is to advance paradigms of computational science and pretty much build an interdisciplinary community of computational scientists at the university. And with this, we hope to enable discoveries to define, society in the next decade and beyond. And one definition of computational science that we like to use is it is a development and the innovative use of mathematical and computational algorithms and models for research, science, and engineering. Which also includes data analysis and interpretation, product development and forecasting. And it is now widely accepted as the third pillar of science, so it complements theory and experimentation. So here at the University of Michigan, there are several opportunities offered that specializes in this field, and they give you a lot of opportunity to engage with other researchers in interdisciplinary computational science. So briefly, MICDE today has over 150 affiliated faculties from 8 schools and colleges from all 3 campuses. The majority, and now it's not a vast majority, it's about 60% comes from engineering, but we do have a large community from the medical school, and of course, literature, science, and the arts from the basic science, but we do have public health, education, kinesiology, information. We have 3 research centers, one related to storage enabled computational science. So when you have very large data sets to work with, but you wanna, you do computational science modeling on them, that's the focus of this center. We have a center, data-driven computational physics focus center, and we have a center for software infrastructure. And to learn about them, we have all the information on our website. We also offer seminar series, symposium, faculty, and student workshops. We have outreach and industrial engagement for our community. And we have our 3 educational programs that we will talk more about today. Of course, these are some examples of the computational science research at the university. So there's modeling blood flow, modeling of acoustics, space and climate research. A lot of it couldn't be done without computation. Public health is a growing community, and right now with the pandemic, you can all see how modeling has had a big impact facing it. There's material science. Of course, all the computer architecture and the hardware comes in too. And of course, mathematics, right? Because without the algorithms, there is very little anybody else can do. Of course, I'm a mathematician, so I have to say that. There's another example for hydrology and of course, physics. And you can name it, right? Computation can be used in chemistry, in biology, statistics, and business and finance, and increasingly in computational science, social sciences. So pretty much in any field you're involved, there is something, or there is a community here that uses computational science. So again, we have 3 programs. We have 2 certificates that are open to all master and PhD students. We say these are lightweight because they give you recognition that you have knowledge of the field of computational science, but they don't say you're an expert. And we have the PhD program that actually opens you the opportunity for a deeper specialization. And we'll go through that. And I believe, yeah. So first, Professor Garikipati will talk to you about the certificate in Computational Discovery and Engineering.
Thanks. Thank you, Mariana. And hello, everybody. To those of you who are new to Michigan, welcome. And those who are continuing, well, great to have you again. So the certificate in Computational Discovery and Engineering that MICDE oversees is one of the graduate certificates allowed by the Rackham Graduate School. Thanks. So we'll very quickly go through the sort of an overview of the certificate, the requirements, and so on. This certificate, like many others, has 9 graduate credit hours that you need to complete, and that typically works out to 3 courses. We'd like you to do these 3 courses drawn from computational methods and applications of these methods. And now, we have on our website, and our website starts with micde.umich.edu, and you can navigate from there. If you go to that website, you will see that we have on there a listing of the courses that are already approved for this certificate. But we will also say that that is not an exhaustive list. There's no way to cover every single computational course that exists at the university because new ones are being created all the time. And the university, of course, is vast, so we don't even try to cover everything. If you find that there is a course that you're interested in, which is not listed on our site, please email us about it, and you can find we will tell you the emails that you can use. You will also find those emails on our website. And in most cases, we found that we can indeed allow you to take the course that you're suggesting. One of these 3 courses can be double counted with another degree. And we also require that you should attend a healthy number of our seminar or webinar series. It's now a webinar series because of distancing and remote access, and our annual symposium. We require that you attend at least 7 of these seminars or webinars. And then there is another requirement, which, there we go. We also have a non-credit experiential requirement for this certificate. And this could be satisfied if you complete an internship or if you're already doing research in either in a lab here or outside of here, outside of the university. In some rare cases, we will allow you to use another course to satisfy this requirement. The last item listed on that bullet point, MDP, refers to the Multidisciplinary Design Program, which is a special opportunity that lets you work in teams of about 4 or 5 students solving problems posed by industry. So these are all the requirements that we have for the certificate and ways in which you can go around completing them.
Sorry, Krishna, I'll interrupt. The MDP option is only for master students.
Right, that's right. Yeah, so that particular option is available only to master's students, not to PhDs, because PhDs are already involved in deeper research-based activity. Okay, all right. So Mariana mentioned that the Institute was established in 2013. It was actually pretty much established around this graduate certificate. We currently have 44 students enrolled in the certificate, and they come from 23 departments, 8 schools and colleges. The histograms below show you the distribution across departments. As you can see, there are a number of students there from the College of Engineering and LSA, but also not insignificant numbers from some of the others, from departments that belong to other schools and colleges at the university. So far, since 2013, we've had 82 students graduate from this, graduate with this certificate. Okay, so how do you go about enrolling? So you see all the URLs you can go to. Talk with your academic advisor. If you're already doing research, you can talk with your research advisor and follow the procedures shown here on this URL. We also point out how to apply if you're a Rackham student, which many of you will be, or if you're a non-Rackham student, which some of you may be, depending upon your school and college. And as you can see, we go into greater details about the requirements for the graduate certificate on this website. This website is also, by the way, the place where you can see what courses have already been approved. Okay. Okay, so that's it. A very quick overview of the graduate certificate in computational discovery and engineering. I'll now hand over to Professor Victoria Booth, who is the director of the next certificate in computational neuroscience.
Hi, everyone. So I'll talk about this graduate certificate in computational neuroscience. So what is computational neuroscience? Neuroscience, and especially modern neuroscience, has become a much more quantitative science that more and more different quantitative methods are being used in conjunction with experimental methods to understand the brain, understand brain processes, brain circuitry, and things like that. And so the motivation and purpose for the certificate is to give students actually formal training in interdisciplinary application of quantitative methods, computational methods, modeling methods to neuroscience. And so in this way, it's organized by both the neuroscience graduate program, which is the main, is the PhD graduate program in neuroscience at Michigan, and MICDE. And so the curriculum, it has the same general requirements as the certificate that Krishna just talked about. But it's, so there's 9 credit hours in coursework, which basically works out to about 3 classes. And we've got them set up so that the classwork, this coursework is both for, gives students exposure to both neuroscience and computational methods. So there's 1 course or 3 credits required in what we consider to be a core computational neuroscience course. And currently on campus, there's 3 offered. There's 1 in the math department, in computational and mathematical neuroscience, 1 in the biomedical engineering on neural engineering, and 1 in psychology on advanced neural circuits. So you're required to take 1 of these core computational neuroscience courses. And then the other 2 courses are to basically be cross-disciplinary. So one course must be cross-discipline from your degree program. So if your degree program is more of a quantitative science like engineering or physics or math, then we want you to take a course that's a neuroscience course or a more biology-oriented course. And then likewise, if you're in a more biology experimental degree program, we want you to take a quantitative course. So you get that interdisciplinary training in the coursework. So that's the 2nd course. And then the 3rd required course would be a advanced course within your degree area, either neuroscience or quantitative. But now you can do the slide. And then the other requirements are 3 credits in a practicum. And this can be fulfilled in different ways. One way is if your degree program allows rotations, you could do a rotation in a cross-discipline lab, or you could do a extended project for one of the core computational neuroscience courses. Each of those courses has part of the course has a project, like a modeling project, data analysis kind of project, and the practicum could be a slight extension of that project. And then likewise, or alternatively, you could do a additional coursework in one of the core computational neuroscience courses. And then also to promote interdisciplinary networking and interaction and communication, we require you to participate in one of these journal clubs. There's a Neural Networks Journal Club, which is run by both experimental and quantitative labs interested in neural circuitry, neural processing, and or alternatively, you can attend the Neural Engineering Journal Club, which is focused a lot on hardware for neural interfaces and more engineering approaches to understanding the brain. And so we require you to do a sort of a moderate number of attending these journal club sessions and to present in one of the journal clubs at least one time. And so really the benefits are to help promote this interdisciplinary training in neuroscience and in applying quantitative methods to neuroscience to students. And this kind of training can be valuable for many different paths out after your degree in terms of course, in academic research, but as well in technology fields related to neuroscience, or understanding the brain, or neuroinformatics. And so to apply how to apply the same kind of process is done for the other certificates. If you go to the MICDE website shown here on the bottom, you'll see the instructions, but the first step is always to talk to your advisor, either your PhD advisor or the program director for your master's degree, to make sure that taking these, if these courses are extra, taking them fits into your training plan. And then as a second step, we ask you to fill out a pre-application form on the MICDE website, and then we'll end up having a discussion with me to talk about your plan, to make sure it sounds good, and then finally to complete an official application form through Rackham. And so now I'll hand it over to Ken Powell, who'll talk about the PhD in scientific computing.
Thanks, Victoria. Hi, everyone. So I'm going to talk about the PhD in scientific computing. Now, this is a joint PhD, so it's kind of fundamentally different from the certificate programs in terms of how it runs. I mean, there's a number of similarities, but I just want to be clear. One of the most important things is that we don't admit students, so you already need to be pursuing a PhD in what we refer to as your home department. So you need to have been admitted to a Rackham PhD program. Then if you want to pursue the joint PhD, to get a PhD in scientific computing, you can talk to us. So there's several criteria, right, or requirements. One is, of course, that your thesis topic and your committee composition need to reflect an emphasis on scientific computing. And in scientific computing, I'm writing that fairly broadly. I think we're really these days including data science in that as well. So on top of that kind of fundamental requirement about the nature of your research or the nature of your thesis, the course requirements have more heavyweight than the certificates, in that you require 3 courses or 9 credits in basically methods courses, and 3 courses or 9 credits in a mix of computer science courses and computing applications that are outside your home department. So methodology courses would sound much like the ones that Professor Gurkapati talked about in the MICDE certificate, in the Computational Discovery certificate. They might be numerical analysis, they might be numerical methods, they might be Bayesian statistics if you're doing data science. And the computer science courses might be things like machine learning, they might be things like parallel algorithms. One of your prelim questions needs to be related to scientific computing. Now, the prelim or qualifying exam is run differently in different departments. So we kind of tailor this to the way that your department runs the qualifying or prelim exam. So we would talk about that in our introductory meeting with you. if you meet all these requirements, then that allows you to append to your diploma the and scientific computing. For example, a number of my students who do this get their PhD in aerospace engineering and scientific computing. Now, I should say that besides the requirements I just talked about, the most important requirement is that you meet your home department requirements for the PhD in that department. These that I've talked about are the ones that then allow you to append and scientific computing. So this program has been around a while. We established it in 1989, and we kind of switched gears a few years ago. Up to 2015, it was a relatively small program. We had granted about 85 degrees, and at any given time, we had about 15 students enrolled. It was across a broad range of departments, mostly in engineering and LS&A, but also in a few outside there. Currently, it's grown quite a bit in the last 5 years, in part because we've been doing these informational sessions, and in part because, you know, there's kind of an explosion of interest in scientific computing and data science. So currently, we have 171 students enrolled. They're across 33 departments, and as you can see, across several colleges. Again, mostly COE and LS&A, but we also have a fair number in SPH, the med school. And lately, we've been kind of branching out into departments that are new to us, things like things in the business school, things in public health, and so on. We have 134 alumni, so 134 people have received the PhD in scientific computing, and 49 of those have come in the last 5 years. So the application procedure, the first I would say, because this is a joint PhD, it's very important that your thesis advisor in your home department be on board with you looking into this. Now, your PhD advisor may or may not know about this. You may be in a research group where students have already done this, which is great. Then you can talk to some of those students to get some ideas. But you may be in a group where you're the first student who has thought about it, and it may be new to your advisor. If your advisor is willing to let you pursue it, then you email the email address given here, and we will set up a meeting with you and me and someone from the staff, probably Heidi Bennett, possibly Mariana would join as well, to talk about how you would want to pursue the program. Basically, in this program, kind of each student has to tailor their program, or I help them tailor their program so that they can both meet their home department requirements and the scientific computing requirements. And I'll turn it over to Professor Dino from the nursing school to talk about the Michigan Institute for Data Science and the certificate in that field.
Sounds good. Thanks, Ken. Okay. My name is Ivo Dinov. I'm an associate director of the Michigan Institute for Data Science, MIDAS. So very briefly, MIDAS and MICDE are two sister institutes. In the Michigan Institute for Data Science, we primarily deal with large, complex, heterogeneous data sets that come from multiple sources, as this table kind of suggests here. The techniques, the methods, the approaches, the challenges that come with large and complex data sets are somewhat distinct from the ones that the Computational Discovery and Engineering Institute deals with. On the next slide, we have the certificate, the Graduate Data Science Certificate Program. Again, this is on the MIDAS website. If you go to Education and Certificate, you can find the academic requirements, the enrollment procedures, approved classes. It's very, very similarly structured as the MICDE certificate program. Again, 12 credits. Typically 9 are didactic, 3 are experiential, practicum, internships, research projects, and so forth. And then we also ask students to participate in the annual MIDAS symposium, as well as regularly attend the MIDAS seminar series during their enrollment in the program. Okay, so most of the students are able to finish the program in about 2 semesters, which is 1 academic year. And the program essentially focuses on several core proficiencies. One is in algorithmic and application developments. One is in data management and data processing. And the last one is on analytical techniques and methods for handling some of these projects. Typical prerequisites for enrolling in the program includes, obviously, since these are graduate programs, an undergraduate degree. Most of the graduate students have that already. We do expect students to have at least exposure to quantitative training during their undergraduate, or if they're in graduate school already, maybe early first step graduate course in a quantitative discipline. We expect them to have a little bit of coding experience. And the most important prerequisite is to have high motivation. Now, these prereqs are obviously complementary to the courses, because every class that you would like to enroll for would have its own prerequisites. So you should choose very carefully your curriculum as you enroll in the program. Now, the classes that you suggest in your application may be part of your curriculum do not necessarily have to be the ones that you take, but nonetheless, the classes that you use to satisfy the requirements of this certificate need to be from the approved course list. Here are some of the competencies. There is 3 basic categories of competencies that we expect students to gain going through the program. The first one is gaining experience in algorithmic development and building applications. The second category on the next slide talks about data management, anything from data wrangling, data harmonization, aggregation, building infrastructure for storing, retrieval of data sets, as well as one of the most important ones is, of course, data visualization. The third competency level that we try to engage students in is analytical methods, and this includes statistical inference, includes designing of studies, including experimental design, including statistical analysis, including engineering development, design, and so forth. And then last but not least, artificial intelligence and machine learning techniques. If you have any questions, all of us are available to provide consultations, specifically more academic, project-related, and curriculum issues go to myself. Kristen coordinates some of the graduate enrollment and requirements issues, and then Tricia Fountain is our education program manager. Thank you.
Okay, and then lastly, I will go over some of the student resources available at Michigan for related to computational and data science. So both MICDE and MIDAS have student clubs. MICDE sponsors the Scientific Computing Student Club that has many activities throughout the year, depending, and these vary within the years, depends on the leadership of the club. The same goes for the Michigan Data Science team that is sponsored by MIDAS, and there are other clubs that you could join that you can find information about in the MIDAS website. As I mentioned before, both institutes run seminar, at this point is webinar series and symposia throughout the year. We do virtual hackathons and other student events. I should mention that the annual symposium, they usually have a poster competition for students. There's also ArcTS, that is Advanced Research Computing Technology Services. This is a group from ITS that puts together and maintains all the high performance computing clusters, data science clusters, and storage. And they have a new data science consulting team that if you would like to start using their clusters or any of their equipment, they can help you. They can help you get started with their with their equipment. Just because I can find a better word. And at the same time, there's a CSCAR that's consulting for statistics, computing, and analytics research. And they also offer free consultations and free workshops, not only for statistics. Like CISCAR was founded some 40 something years ago, and you could go and ask questions, statistical questions. But now you can, they have experts, and I think most of them are PhDs that can answer your questions about scientific computing and data science. So if you're running codes that are getting too large, or your data is getting too large for your laptop or your small system, you can go with them and they can help you get started to parallelize it and so forth, right? The consultations, consulting is free up to a point, and then there's a fee. And they have a lot of free workshops that they run throughout the year on how to use many of these things, from basics of using the command line and logging to the cluster, to how to use TensorFlow, how to RStudio, and many others. So I really, even if you don't enroll for any of our programs, I really encourage you to look at their workshops. MICD, for the MICD students in the MICD programs, we also have a $4,000 top-up fellowship that if you're enrolling in one of our programs, it's a competitive fellowship, but you can apply for it. And the fellowship is can be used to travel to conferences, to buy computers, to buy time in computers, and other things related to your research. And finally, for students not in the in an engineering program, you are allowed to use a cane system. And this is important because a lot of the College of Engineering has software that a lot of the other schools and colleges doesn't have it, but if you're in one of our programs, you are able to use it. Finally, so a few of the events and activities that we have for this fall in 2020. MICD is having a workshop on resilient cities through computation. That's on October 9, which will include a student hackathon. MIDAS is holding its annual symposium on November 10 and 11. And we're running a webinar series and other virtual events throughout the fall and the winter. I'm gonna go through some, first through some questions that some of you asked when you fill the form to register for the session. So if, one of the questions was, if you can be enrolled in a master's degree and a PhD program, because some students do that. You can still sign up for a certificate, but of course, the first thing is to know that you actually can cover all the requirements for the 3 programs. And the other thing, for the double counting, you can only double count with 1 program. So just an example, we had today that a PhD student actually enrolled in 2 masters and the certificate. So in that case, you can only double count 1 course either between the certificate and the master, or the 2 masters, or you cannot do 1 between the masters and 1 between the certificates. So if you enroll in a master's and a certificate, just make sure you have enough time and credits to cover the requirements. The next question is about the tuition, regarding tuition for the PhD in scientific computing. And in here, it's, well, I'm gonna read the question because I'm just, it says, for the PhD in scientific computing, how will the tuition be assessed? And is because the students department said that the PhD student can only take 1 class each year. Oh, sorry, I believe it's each semester after candidacy, and that still holds. So that's why we recommend you to enroll early, so you actually have time to complete all the credits, all the credit requirements for the program. Because if you enroll by the 3rd year, then it's very unlikely that you will have time to complete other 12 credits, right? So It's always on our case-to-case basis, but we do recommend you to enroll early for the PhD program. And then the last general question is are these programs provided every academic year? And yes, the programs are offered every year, and the enrollment is rolling for all of them. And I'll talk about the enrollment deadlines in just, oh, they are on the screen, so I will talk about them now. So for the certificate.
Oh, sorry, Mariana, sorry, I'm going to interrupt you for just a second here.
Yes.
I was just looking at the chat and I see there's another question. There's a question on the chat. I'll just read it out. It says, is it possible to attend webinars this fall if you have not yet applied to the program?
Yes, you can attend the seminars, and there will be the option of watching them later. But for that, please either use your unique name or your full name, because when we actually check that the students attend this webinar. So even if you haven't enrolled, just make sure to put something there that will help us identify you and make sure it's counted towards the number of seminars you will attend. Oh, thank you, Krishna. Okay, so then about the enrolling deadlines, and this can be confusing. So if you want to be considered for enrollment in the fall, you have to apply by August 1st. And if you want to be considered for enrollment in winter, you have to apply by December 1st. But this only matters, for example, that if you wanna graduate in the fall, because you cannot enroll and graduate in the same term. You have to enroll before the term starts. So that's what these deadlines are important. Sorry, I lost my train. But you can start taking classes now, and they would be counted towards the requirements of any of the programs, even if you're not officially enrolled yet. I hope this makes sense. So for the PhD, again, the enrollment is rolling and there's no deadline, but you have to consider the time it takes to finish all the requirements, and especially you have to consider the requirement about your prelim. And then for international master's and PhD students, that you pay a $500 fee for entry. That is a one-time entry, and enrolling in these programs won't cost you anything else except the $10 for the certificate. But there's there's not a second $500 fee for any of these programs. Then other common questions are, what are your choices as a master's student? It's only the certificates are available. So what if the courses you like to count toward the certificate, if they're not listed on either of our websites, you can always contact us either at MICD contact or MIDAS contact. And we are very likely to accommodate you, but we have to review the syllabus of the courses you want to take. About how to choose what to do, it all depends on your interest, your background, and what you want to do in the future. So that's hard for us to answer, but if you want to talk one-on-one, and we can try to help you figure that out. And then again, if there are a fee to apply, yeah, the fee was added last fall in October 2019, and it's $10 non-refundable. So please follow the procedures first, talk to your advisor, then fill the pre-application form, meaning not the Rackham. And after everything is set, then you apply to Rackham and pay the $10. The last question that I already touched a little bit is if you have to wait to be enrolled to start taking classes toward the programs. And the answer is no. You can actually use courses that you have taken at the University of Michigan within the past 5 years to fulfill their certificate or the PhD requirements. But of course, you have to make sure that they are graduate level courses. So that's most of the 400 level and 500 and above. And that you haven't used those credits to fulfill and there's a typo there, but an undergraduate requirement. So if you already use them to complete other degree, you cannot, your undergraduate, as an undergraduate, you cannot count them towards the certificate. And lastly, you have to make sure these courses are approved for the program. or you have to seek approval before assuming you can use it as a requirement. Then here is information if you have questions. So for the MICD programs, you can go to micd.umich.edu/academic programs, and all of them will be listed there, including the computational neuroscience one. And if you have questions about the certificate in data science, go to midas.umich.edu/certificate. Finally, if I get this to move. And if you have questions specific to any of the MIC and MIDAS programs, please check your email for links to the breakout rooms, or I believe they are pasted in the chat, where you will be able to ask questions within a smaller room, group, and those rooms will close on the hour. So, and I believe you can join one and then switch to the other until, yeah, I guess 5 o'clock. So let me check the chat, but if there's any other questions here. No, apparently not. So please, again, if you have more specific questions, join the chats. Otherwise, look at our websites or send us an email. And thank you everyone for coming. We'll share this presentation and the slides on our websites. And let us know if anything else comes up, and we'll be happy to help you. Oh, I should say, if you're interested in the data science certificate, you can stay on this session, and Professor Ivo and Trish will stay here to answer your questions. Thank you again.